So immediately you'll have a question, Bhagwan, you're talking about AI types and AI technologies, right? We looked in the morning session, AI types and AI technologies. What is the difference? So if you remember in the morning, we looked at AI types where we categorized based on ability, based on functionality, whether it is visual, or whether it is text, or whether it is interactive. If you look at the functional AI, right, it's more of the functions where most of the applied AI use cases are, most of the applied AI apps are, where the AI solutions are. Well, let's look at the AI types. So on the left, we have seen the ability, right? Let's not focus too much on ability. Right? This part is very clear. Right? This part is very clear. Now the focus is on functionality, reactive machines, limited memory, theory of mind, and self-awareness. So this was in the morning, right? We looked at functional AI, where we examine huge amounts of data for patterns and dependencies in a particular process. And this helps to regulate several tasks in speed without any fault. So what are reactive machines? Most of the time, reactive machines are a responsive, resilient, elastic, message-driven. Right? They can't create memories or use past experience to shape current decisions. They cannot learn. They cannot improve over time with practice. Right? They are machines which are basic. They do not store memories or use past experiences to determine future actions. They simply perceive the world and react to it. Now, what is limited memory? Limited memory, on the other hand, has ability to look into the past and improve over time, can learn like human being, can make decisions, his ability to absorb learning data and improve over time. It can form a reference model to solve future problems, ability to look into the past, can complete complicated tasks, can use historical data to make predictions. So this is what is called type 2 class, where there's a limited memory, and it's supposed to be the second most sophisticated of AI systems. On the other hand, there is theory of mind, right? Understanding that others have intentions, desires, beliefs, perceptions, and emotions, and which are different from one's own, that such intentions, desires, and so forth affect people's actions and behavior. Good examples are Sophia and Kismet. Kismet is from MIT. It's a robo. And you have Hansen Robotics, which has created Sophia. Both characters, I think, very popular in Hollywood. I don't know whether you've seen one of the Al Pacino's movie where you have Sophia is being created by Al Pacino. And Kismet, I think most of the time you see in Star Wars and a couple of other movies. Moving on to the last part, self-awareness. Machines are aware of and understand the emotional and mental state of others, but with self-aware AI, machines will have their own emotions, needs, beliefs, and possibly even desires. So enough of theory and types. Now let's get to technologies, right? For last 3-4 hours, Bhagwan, you have been talking about types, categories, and lot of abstract concepts, but where do they get applied? What are these technologies called? Right? Machine learning, neural networks, robotics, expert systems, fuzzy logic, natural language processing. So Bhagwan, I'm interested in these technologies. I want to see them in action versus the types of AI or types of technologies or categories, right? That's most of the time many people have when I present this to the audience. So answer is, let's jump into the specific areas like voice assistants and chatbots, right? What is the technology behind them? It's called cognitive science. You have cognitive system, you have system entities, you have service system entities, mediators, and you have rights and responsibilities. And if you see here, the entities, right? This part, like if the entities were, it's almost like NLU and NLP parsing and identifying the parts of speech, within parts of speech, identifying the proper nouns, common nouns, and nouns. And we have rights and responsibilities, sometimes intents, sometimes functions, right? And also you have mediators, which will help integrate the chatbots and voice assistants with the cognitive system. Good example is Watson, which is very famous. Also, we have Google Dialogflow. We have Amazon Lex. There are a couple of others. With.ai. You can also create your own chatbots, and some of the operating system had, or some of them have software. Like for example, Eliza is one of the famous chatbot, which was there in the old days, where people get bored in their Unix systems. They started chatting with Eliza on a terminal mode, right? So that these are some examples for cognitive systems. So that's the example, and let's move on to the next slide. So this is about enterprise AI applications. So the next question most of the audience has, Bhagwan, you talked about so many abstract concepts. You talked about technologies and you talked about how cognitive science is applied. In enterprise, in companies, in verticals, in various domains, where are these really applied? Right? Like chatbots, you have location intelligence, media search, recommender systems. So on the left-hand side, right, you see you see on-premises, private cloud, public cloud, and you have online services, you have web services, right? You have various computer networks, desktops, telecom centers or infrastructure, right? And you have smartphone devices, employees using them. There's an online shopping cart and e-commerce, right? And you have databases, RFIDs, networks, packaged application, custom applications. In a typical enterprise or a company, you have all of these either on-premises or private cloud or public cloud. If you look at some of these technologies, where do you apply these? We have text, video, images, some kind of content coming out from all these packaged applications. You have search engine, you have auto match, you have machine learning algorithms, you have location intelligence, you have media search, recommender systems. All of these work on the specific data. If the customers are on e-commerce online center and they're doing online transactions, right? You have recommender systems which are looking at analyzing customer transactions and see how to recommend for a particular customer based on his profile, based on his transactions and behavior. And you have media search and search engine and analytics over the usage. So any questions at this point? So one person has clarified, we have gone through the basics, but not detailed theory and implementation of different techniques regarding the previous FDP, right? Machine learning and data science. So I've created a poll, please vote. We'll just take 2 minutes for this poll. Any questions so far, please post.
All the participants are requested to take part in this polling. Please do click on the link mentioned in the chat box. Submit your vote.
So there is a question, sir. Nowadays we can see chatbots on different websites. So can you tell us about the background technologies in terms of accuracy in responses? So we have tomorrow another section where we'll focus on chatbots, conversational technologies. Anyway, in any case, I'll give you a short answer. So in most of these chatbots, right, you have intents. Right? Intents are like questions, keywords, right, phrases, and they are being trained. And what are the responses, right? So maybe I'll put the response here. And these responses can be generated. They can be picked from the training phrases. And in the output side, you have chatbots, which are you have what you call terminal, web, you have mobile chatbots, right? You have voice-based chatbots. So the background technologies pretty much look like these, where it is Watson or Dialogflow or Amazon Lex. I hope I have answered your question. So regarding the previous faculty program, the number of votes are only 11. We have around 22. I'll give another 2 minutes. Meanwhile, any questions? So there's another partial question about chatbots in terms of accuracy in responses. Like in any technique or any algorithm, it's the number of training phrases, right? How the model is created, right? How the model gets trained, tested, validated. So the accuracy depends on the training, testing, and validating. So regarding the poll, the number of participants is still at 11. 5 feel that they have attended, 4 no, and 2 are partially. So we'll continue on the presentation, and nobody has any other questions. In the enterprise where technology, AI technology is being applied, the first area is the predictive analytics, right? You have proactive intelligence, command control, actions on objective, installation, exploitation, delivery, right? Reconnaissance, weaponization in terms of in defense, right? But the first step where the proactive intelligence gathers all this information, right, through command control and has actions on objective and gives the feedback to command control saying that this is the step you need to work on, right? And there is prevention and there is also prescriptive analytics, right? What is the right thing to do? Now, that was about different companies and defense and even for enterprises to take decisions. But let's take a practical problem and see how it is applied. Right? That'll help us to correlate in terms of what are the problems. Like in the morning, there was a question, right? Do we have different types? How do you go about picking the right type? How do you go about picking the right algorithm? Well, let's look at the customer segmentation, right? You have various customers. Customers are from different geographies, different gender, age. Now they have different relationship managers. Now, let's say you are building a predictive analytics platform for, let's say, a retail company or a telecom company, where there is huge customer data, there is real-time operation data, there is social media data. I am muting all of you unless if you want, you can unmute if you want to talk. I'm also working from home. Children might come, but in terms of continuing on the presentation, I'm muted. Feel free to unmute whenever you want to talk. So you have, it's a big data. It's huge amounts of data, business intelligence data, social media data, shared data, high fidelity, real-time data. Right? Now, how do you go about taking this data and think about the future? And of course, today's is very easy. You do the reporting and identify them by geography, by gender, by age, and you can pick various categories and group them and cluster them, right? Now, the future is very, very important, very challenging, right? Like this customer might shift, let's say a telecom company, shift the telecom carrier, and he may not pick our product if you're a product company or if you're like a company like Amazon, where you're distributing a product, set of brands. You may not pick from the Amazon, but he may go to Flipkart or you go to some other online e-commerce. So that's where the future is very, very important. How do you develop customer retention? How do you create customer loyalty? How do you, what do you call, do campaign management? How do you, publish the loyalty programs? How do you execute the loyalty program, right? So first we create a customer profile. So we do the profiling and various offers are created, campaigns are created, and you have loyalty programs where The transactions are grouped and identified, and then you have loyalty points based on the transactions, right? Now, you like many of these programs, loyalty programs, we have various levels: first level, second level, third level, or bronze, silver, gold. There are various names, right? Basically, the goal is set to the customer to raise above the normal or the current to move to the next level, right? People have seen gold, platinum, and diamond, right? It goes on to 4 or 5 levels. The idea is based on the loyalty, you target offers, right? We're looking at the transactions, you target the customer for the next best action. Or he's searching for, let's say, TV. What are the correlated products where we can send in the offers, not just the offers for TV, right? So that's the future, right? What will the customer buy? How can we use analytics to predict what customer is going to do? How do you prescribe what customer has to do? So we stage the data, we cleanse the data, we mine the data, and use machine learning techniques to predict what customer is going to do, and use that information to prescribe, to send offers, to improve loyalty, to improve retention, right? So that's the goal of the predictive analytics platform. Now let's get into more on the mathematics, right? How do you go about measuring the churn? A lifetime value of a customer is average value of his sale multiplied by number of repeat transactions multiplied by average retention time in months or years for a typical customer. We also have another metric, which is the acquisition cost. How much I'm spending per customer per campaign, and how many customers am I retaining, it's in a time period per month, right? Who over a given period of time repurchase when compared to an equal and preceding period of time. So these are very key, three important KPI or process indices or metrics which you have to keep in mind if you are focusing on customer churn, customer retention, customer experience, right? Now, how do you go about doing the customer retention? So there are various factors, right? I mean, customer liked our product, customer did many transactions. We offered multiple offers. But when you do the survey, you'll be surprised that there is a human being even in the outcome, in the result. Like in the morning, we were discussing about super UI and AI and so what you call singularity. You'll be surprised that the consumers like how the customer relationship manager or customer service manager treated me when I called. That's the reason I'm either staying or leaving, right? So we talked about so many AI algorithms and so many data analysis and so on. But at the end of the analysis, even the AI algorithm found out that this human being or the human touch is very important to retain a customer or lose a customer, right? Very surprising after all that super AI and so on. So that's a good example which I presented on prescriptive analytics or predictive analytics, where it's a real life example where you have set of customer data. You can be a retail chain or an e-commerce chain or a telecom company where you're focusing on customer data and predicting customers churn, right? Or predicting prescribing how to retain your customer, sending offers, campaigns, right? So that was the session about customer retention. So now many of people have this question. Bhagwan, you talk great things about AI technologies, different areas, right? And you also you picked up a case study and presented. But what is next? Looks like you have covered everything in a whole spectrum of technology. So let's look at the next level. Cloud vision. So we looked at computer vision, but what if we have all these algorithms on the cloud? Right, for object detection, image recognition, video analysis, video processing. So this is where I'll present slightly different view about computer vision from the morning's video.
Let's start with what computer vision is and why computers need vision.
Sure. Computer vision is an area of computer science, and well, let me just start over. In computer vision, we try to teach computers how to see, and that seeing can refer to understanding scenes, reconstructing 3D objects, recognizing objects, avoiding obstacles, helping blind people navigate. And a lot of this makes use of machine learning, and it also makes use of geometry and applied math. There are legends about how it began as a summer project.
Given to someone who's actually now a professor at MIT, Jerry Sussman, and Marvin Minsky said, okay, for this summer project, why don't you solve the computer vision problem? Okay? Shouldn't take that long. And wrote a little outline of what he was supposed to do. And then that's kind of what the field's been working on for the past 40 or 50 years.
The term computer vision hasn't really appeared in the popular media that much until recently. Part of that is because when something became successful, it got renamed. Like barcode scanning is an instance of computer vision.
Computer vision is also responsible for the yellow first down line that you might see watching football on TV. It helps stabilize videos and create virtual worlds. It helps cameras see faces so they're not blurry. And it's getting better at recognizing what's going on in a video, making whatever it is you are searching for on YouTube a little easier to find. A lot of the videos on this channel have previously touched on a specific example of computer vision, but here I want to zoom out and give you more of an overview of what computer vision is. So the next time you see those two little words, you'll have a deeper understanding of what they are. What's the differences between like human visual systems versus computer visual systems?
From the computer perspective, the image is really just an array of numbers, or if it's color, it would be 3 arrays of numbers.
By themselves, these pixels don't mean anything to a computer. The computer has to interpret what they are. And in general, there's 4 approaches for how it does this.
There's a lot of work by the field on object recognition. Given a photo of something, where are all the objects and what are they?
That is very close to solve at the generic level, meaning that it is a tree, not that it is a very specific type of tree. That remains somewhat challenging.
Another direction is physical reconstruction. So if given a photo of something, what's the 3-dimensional shape of everything?
If you think of a Google Street View van going down the street, capturing spherical panoramas, that data it captures is still 2-dimensional, but when you feed it to algorithms that match features between those images, you can produce these 3-dimensional images.
Hello, Bhagwan sir. I think audio is not there for video.
So what you have seen is pretty much how the computer vision is happening on Google Cloud. It's similarly, AWS has recognition where you run the algorithms on AWS, like Amazon Web Services. Amazon has recognition. Similarly, IBM has what you call Watson to you for computer vision, and you can use those algorithms like Watson ML and Watson computer vision algorithms to run on IBM Bluemix. So we have a couple of questions. In ML algorithm also, we have to apply input and how it makes it different from AI algorithm for recognition. That's a very good question. Are you able to see the screen?
Yes, sir.
So let's start off with AI models, right? And like you rightly asked, you have ML algorithms. Right? So what is the link and how do you go about applying input, and what is the difference between AI algorithms versus machine learning algorithms or statistical algorithms or heuristics? In a simple algorithm, you always have input data, right? And you have output data, right? It's very simple model, right? We have written computer programs where they read from the data, right? And then you have the output. So what's the difference from the standard machine learning algorithms versus AI models? The first thing which you need to remember is learning, right? And second thing is it always has history, right? Knowledge, right? Like a knowledge base. And there is a training algorithm which trains. And the last but not least, and very, very important, is testing and validation of the model. So this part needs to be done to take an algorithm and use it using an ML algorithm or your own heuristic or a custom algorithm. Now, another important difference in the output, right? Now, let's create the differentiation. See, the output is there even in this case, but there's a small difference, which I'll show in a second. Then output comes here, right? And this output is based on the training data or the testing data and the validation, or it is associated with kind of scenario, right? And this scenario has to match with these scenarios. If there's a mismatch, this becomes an unseen scenario. Right? And you take this data to improve your model. The way you improve your model is you enrich your scenario or update the scenario with this new unseen scenario. Let's say it's a normal scenario, it's not unseen scenario. Then the output is presented and you calculate. Again, there's a big difference. There are a set of metrics which are calculated. Tomorrow we'll get into the details, but which is called true, false, what do you call, confusion matrix, right? Confusion matrix analysis. right? And this confusion matrix will create, based on that matrix, we can create metrics like bias. We use metrics like F1 score, precision, right? Immediately you'll ask Bhagwan, can you do the same thing for the input into the standard algorithms or just an algorithm which takes input data? You can, but you don't have the training data information. You may not have done the learning part in the machine learning. You may not have a model at all. You just read the data and then execute the algorithm. So that's the difference. I hope I have answered your question. So there's one more question. In the video, there was an example of Google Lens as it can detect the image scan, but as an image is a huge combination, as an image is a huge combination of pixels. How can we prove it to system as an input in the form of bits or set of RGBs? So very good question. And in fact, there are a couple of chapters in most of the books I have read, right? And maybe the video did not cover the full detail. So I will try to present it a slightly different way using the concepts which were given. So basically, you have a pixel, right? We're going to cover this in the tomorrow session also. I'll just briefly present it here. And you all know that a pixel will consist of what you call RGB, right? And values. Now, using these values, it was presented in the video, computer recognizes. But there is little more, right? So for example, what is the image size? Right? Like for example, height and width. There's another important factor which was not covered is resolution. Right? These are some of the terminologies which are associated with image as a content. What is the image resolution? What is the image size? What is the image height? What is the width? And also, he showed, I think the first person in the video was showing that you start off taking the video, taking the image, gray it out, invert the image, right? Grab which is black or gray or white, right? So something very similar to that will happen, right? Based on the size and based on the resolution, and grab the areas where the colors are, where there are no colors, where there is noise, right? That's the first step in any image recognition algorithm. After it's identified, let's say, for example, you have identified this is the critical area. So somewhere here there is white, somewhere here there are dots, it's somewhere here that's again white, it's some dots here, it's some patches, small patches here and there, but main action is somewhere here, right? And then you have a coordinate system to help you out. I'm just presenting Java's coordinate system. Use Java image. It's something along those lines, right? X and Y. Now, once you know that this is the area, right, and you identify the pixels based on the resolution, you identify the colors, and based on the colors, you can pretty much create a particular map saying that within specific area, or within a space, within every pixel, this is the color, right? You have the data information. So image recognition takes this information, creates a particular score, right, or some kind of hash to compare it with various objects, right? Because the main action is happening here. In image, they have shown, I think main action was like a sofa or a dog jumping around, or they have shown some of the images like recognition algorithm, like objects moving. The main action is there is an object in the middle, right? And that middle object is a human being who has head, nose, and so on, right? So the goal is to compare these areas with other objects. Once start seeing there are two hands and there's body, there's legs, right? The next level algorithm will start checking for where are the eyes, right? Face detection, what is the nose shape. As you drill down to the next level detail, you can start comparing with the objects. So like I always said in AI, having a knowledge base is very important, right? Having training data is very important, right? And this image processing algorithm needs to use this learning algorithm, right? And it has to compare with the object which are there in the knowledge base. And are these scenarios covered within this image processing algorithm? So all that remains same, even image recognition or object recognition. So I hope I have answered your question, but I'll spend probably tomorrow around 15-20 minutes just on this, where we get into more detailed examples and practical examples. Any other questions? So moving on to the presentation. So what's next? Well, after cloud vision, what is next? So they touched upon in the Google Cloud that one of the use case is related to autonomous cars. We'll just get into more detail. What is self-driving? What is autonomous driving?
You've probably read something about autonomous vehicles in the news, but what are they and how do they work? Well, they use sensors, lasers, and cameras to navigate the roads, and there are...
Are you able to see the video and hear?
Yes, sir.
You've probably read something about autonomous vehicles in the news, but what are they and how do they work? Well, they use sensors, lasers, and cameras to navigate the roads, and there are actually 5 different levels of automation. Today, your car is at level 1 with features like cruise control and parking sensors. But by level 5, the car can drive itself completely. All you do is tell it where to go. But what does that actually mean? Well, with computers at the wheel, you'll get from A to B faster with less congestion and less pollution. Once you arrive, your car will even park itself. But their biggest benefit is safety. Every year, more than 1 million people are killed in car accidents worldwide, and 90% of them are caused by human error. Sometimes we get tired, we lose concentration, and every now and then just get it wrong. Could driverless cars be safer? We'll have to be able to make quick decisions in all kinds of situations and share the roads with conventional vehicles, pedestrians, and cyclists. There's still a lot of work to be done, but driverless cars could dramatically cut the number of accidents on the roads and save millions of lives. That doesn't make letting go of the wheel any easier, though. There are still lots of unanswered questions. Who's to blame if there's an accident? Can autonomous vehicles be hacked? Or what if you're someone who just likes driving? To find out more about what an autonomous future might mean for you, visit FIA.com.
Any questions? So if you don't have any questions, I'll move on to the next slide. Or if you can think of any question on autonomous driving or self-driving driving, feel free to post the question. So the next area which is evolving is creativity, right? How do you go about making AI creative, right? So we'll just look at how creativity is evolving in the AI area. Please confirm if you can see the video and hear us.
Yes, sir.
Take a look at these two pieces of art. Which do you think was made by an AI? And which do you think was made by a human? I'm sorry, it was actually a trick question. They were both made by an AI. We like to think that creativity is the one thing that sets us apart from everything else, be it animal or machine. We humans, or so we like to think, are the only ones capable of conjuring up something new and valuable just by the merits of our own imagination. But recent developments in artificial intelligence, or AI, has thrown into question this distinctly human characteristic. AI has been able to produce art, write music, and even generate poetry. So, in this video, let's explore AI and their creative works and begin to question whether creativity really makes humans unique. This is the portrait of Edmund Bellamy, a painting produced by an AI, which was made by the Paris collective Obvious. This painting was generated by using an algorithm and a dataset of 15,000 portraits painted between the 14th and 20th centuries. This portrait is what it came up with. The piece is even signed with an algorithm used to create it. Okay, now I know what you're thinking. It's a bit rough around the edges. And yes, I'd give you that one there. But remember, a machine made this, not a sentient being capable of thought. Would you like to know how much it sold for? Well, it was expected to make $10,000, but at auction, it sold for $432,500, nearly 45 times its estimate. AI has officially entered the art world. And if this painting marks the start of a trend, AI painters will be fast outselling humans in the years to come. The AI behind these abstract ink prints were developed by a New Zealand-based artist, Tom White. Much like the paintings from before, they were created by using a neural network trained to recognize thousands of images in its database. When asked to produce an image, for example, a rabbit, it will attempt to make a representation of one by using the many thousands of images to work from. And you'd get a painting a little like this. Other works include a chicken, a killer whale, and a cello. These ink drawings are not accurate one-to-one renderings of the original image, but they're not intended to be. They're abstract paintings, much like the works of Kandinsky, Picasso, and Miro. The emphasis is on color, shape, and line, not necessarily on realism. If you ask me, the fact that a machine, incapable of thought, is able to create these kinds of abstract works from scratch is astonishing. These two projects are just a selection of a growing movement of AI artists. There's a fascinating website of the same name that showcases their work, and I highly recommend giving it a look. There's artists like Mario Klingman, who have developed neural networks that generate antique portraits in real time, or Google's former artist-in-residence, Song-Wen Chung, who has built an AI that can draw alongside her to make these fascinating duet paintings. And finally, these real-time simulations made by Rafiq Anadol conjure up imagined buildings, objects, and people based on millions of images in its database. It's a process he describes as machine dreaming. Surprisingly, the world of AI and music is a bit more established. There's There's a great variety of musical compositions and songs that have not been made by humans. Take, for example, the Luxembourg-based AI composer, Ivor, a program that is able to produce soundtracks for a bunch of musical genres, especially classical. Recently, he wrote his first rock song, On the Edge. Now, for rights reasons, I can only play a small sample. Here it is. Ivor has also gone on to co-produce 2 songs, Lovesick and I Am AI, with singer Taryn Southern. You can have a listen to them in the links below, as well as sources for everything else discussed in this video. I'll also add a link to Ivor's own Spotify profile, where you can listen to more of its music. Perhaps the reason why music is much more easily replicated by an AI is that music, especially Western music, is built up by a series of rules, regulations, and guidelines. Harmonic intervals are set in numbers like thirds, fifths, and sevenths. The duration of notes are organized by fractions, like half notes and quarter notes, and certain musical pieces must fit into algorithmic structures, like most pop songs have the algebraic AAPA shape. Admittedly, I'm simplifying a bit here, but there is a strong case to be made for mathematics underpinning music. And since maths is the language of artificial intelligence and coding, musical compositions are something that can be replicated by non-sentient machines with relative ease. Another creative enterprise AI has had a go at is poetry. As with music, poems often follow rules and structures that can be programmed into an AI or an algorithm. For example, a Shakespearean sonnet follows these strict guidelines. A Shakespearean sonnet is 14 iambic pentameter lines divided into 3 quatrains and a couplet. The rhyme scheme is usually A, B, C, D, C, D, E, F, G, G. Each quatrain presents one idea. The rhymed couplet usually ties the whole composition together by succinctly stating the main idea. Technical jargon out the way, this is all to say that poetry has some specific rules. So let's see an example. First is Shakespeare himself. Let those who are in favour with their stars, of public honour and proud titles boast, whilst I, whom fortune of such triumph bars, in looked for joy in that I honour most. This one was created by IBM, was full his light, so long upon his train, he softly left from dark of shining plain, and to the morn to set her on her way, and all her fellowship was passed away. Now I'm not sure what either one is actually saying in their sonnets, but it seems that not even the genius of Shakespeare is fully safe from AI imitation. But I'll let you be the judge of that. And now for some nature haikus that I came up with along with the help of an online generator. Dampish a forest, a common strong ant wallows, watching the puppy. Windy afternoon, a more passionate fish trots because of the fly. Shaggy eventide, when a fallow, dry deer sneers under the best friend. Okay, not my best work. Blame it on the AI. Looking back at these paintings, songs, and poetry developed by AI, and all begs the question, are they really the product of a creative artificial intelligence, or is it simply the work of genius software developers who are behind it? If you ask me, I suspect the latter. The real credit for these works is probably owed to the developers. They were the ones who constructed them, wrote the algorithms, and ultimately dictated what type of creative works the AI would make. At best, AI can replicate, but not create. For example, the machine that made the portrait of Edmund Bellamy is incapable of producing those abstract paintings that Tom White's AI could, simply because it's not been programmed to. Each AI system can only make one type of predetermined painting, so the machine is not really being creative by itself, per se. But it's only a matter of time when AI will be able to produce works not planned by its creators, works that are new and valuable in their own right, independent of human interference or predetermined programming. And once that happens, we'll no longer be able to say that humans are alone in possessing creativity. The 21st century has only just begun. The fact that machines are already producing paintings, music, and poetry in the first place is a sure sign that the next major creative movement, non-human art, is already on its way. Thanks for watching this video.
Any questions? Please post any questions if you have.
Dear participants, if you have any questions, please ask your questions in chat box. Then you can either unmute yourself.
Was there any question?
I think sir, there is no question.
Okay. So if you don't have any questions, I just wanted to share one more, which is related to creativity, so that you can all actually try it out instead of making it completely abstract. It's called devart.withgoogle.com. Right? You can actually go to the site. So I'm going to share this, the chat window, and try out and see how AI is helping out in creating an art which is supposed to be creative. Right? How AI can get into area. They have put many of these projects online, and you can actually see them in action.
I'm trying to bring joy to people, make people smile. I'm trying to create strange, unique moments for people.
Everybody can hear and see.
Yes, sir.
My background is in fine arts, and I studied painting and printmaking, and I'd always loved animation. I love this idea of animation as bringing something to life, and this idea that you could write code and breathe life into things, for me, was really fascinating. A lot of the projects that I do involve gesture, involve drawing. What does it mean to make a mark? There's something really kind of fundamentally important with putting a line down on a piece of paper. That's like saying I'm here. And a lot of what I do is ask those what if questions. What would it look like for a line to uncurl itself? And you have to write the software to see that answer. And I think we need a culture of poems. I use the term poetic computation to describe what we do. For me, poetry is the right words in the right order. Code is also the right words in the right order. It is a very economical amount of words and very specific words that tell the computer to do specific things. What's happening a lot now is that we're winding our way into these museums through the back door. The next generation of curators coming up will have grown up learning processing and learning these tools and being part of these communities. And so as we grow up together, there will be more and more accepted into the art world. A lot of the stuff I do is in code, but when it comes to building stuff, I spend a lot of time looking at materials. Use speakers and components, and sometimes it's really useful just to get ideas. There's data all around us, and one phenomenon is that you jump into a taxi cab and you have no idea what music is going to be playing. It could be talk radio or sports or Senegalese music. My dev art proposal is called Play the World. It's a keyboard where you press a note and it finds that note that's happening live in audio streams from around the world. Always these projects start with a crazy idea. One of my responsibilities is to get myself in trouble, and then the act of making the work is getting yourself out of trouble.
So that's about DevOps, right? And there are areas where you can actually go in and try it out, how it looks. So I just shared the link. Did everybody get the link to go through these languages and how DevOps can be used? Everybody can able to access this particular page. So these are some of the things which you can quickly catch up. The other things which I wanted to show was related to dialog flow. There's one more slide. I'll just finish that slide and come back to here. Just give me a minute. So there's another area which is evolving, like we are like art. Can computer or AI algorithm code? So there's a new concept called AI coder. Can we have a programmer who can be AI? Right. So that's the evolving area, and there are websites where they talk about this. So you can look at some of these links to get started. I hope everybody has access to my book, right? Please type it in the chat window. Everybody are able to access the book. So this is the book which is available online. You can also access the code. Just give me a second. I'll just show you. I think it's available on the Appress site. I'll share you my book's source code also, so that you can start looking at some of the source code for tomorrow's session. We'll get into code, run specific machine learning or AI algorithms. This is the link which I'm going to share has more details about my book. So you can download the source code for my book. And if you have any questions related to AI algorithm, this talks about quantum AI algorithms. And also a little bit basic, more or couple of chapters are related to mathematical operations like matrix, set, tensors, and quantum operations. So chapter 3 focus only on quantum computing, which may not be of interest for you. 4 again is algorithms, quantum algorithms. Chapter 5 is quantum circuits, quantum assemblies. Chapter 6, from chapter 6 onwards, we get into quantum algorithms or quantum AI. So chapter 8 looks in QNN. This is where I was mentioning. Neural network is AI and QNN is quantum neural network. Right? GAN is our AI algorithm. QGAN, right? Generative adversarial network. Here in quantum, in the chapter 9, we look at classifying algorithm, support vector machine, variational classifier, and also we look at the iris flower data analysis within this chapter. Here K-means clustering algorithm, chapter 10. Chapter 11 is more of random walks, mathematical, what you call probability related algorithms. If you are familiar with simulated annealing, quantum annealing is very similar. That is chapter 12. Chapter 13 gets into more of quantum teleportation and entanglement. So from chapter 9 to chapter 12, you can start looking at the code. And the book also. And I have my own GitHub repository. And you can start looking at the chatbot's code. I'll just give a small demo. Meanwhile, any questions, feel free to post.
I think there is no questions from participants, sir.
Yeah, I'll just show the demo and then
Yeah. Thank you.
I have shared the banking chatbot code, which consists of some of the intents, like address change, annual fee, check my account balance, checkbook request, credit card transactions, credit card balance, credit limit increase, current account, debit card, fund transfer. Let's look at one of the checkbook requests, right? You can all create your own chatbots on Google Dialogflow, and this is the link. So training phrases, please issue a new checkbook. The request is checkbook request. The response will be your checkbook request is taken. We'll get back to you with the checkbook mail in 3 days. Right? Very simple, right? So let's try it out. So I said hi, it says welcome to Bank XYZ. Please share your query. So I just vary it. I don't put the exact training phrase. I'll just put I need a checkbook. Right? Intentionally vary it. So it recognizes saying that he is asking for a checkbook. The checkbook request is taken. We'll get back to you with checkbook by mail in 3 days. So let's take a slightly complex one. Where I want to check my account balance. Here, account balance, what is my account balance? I would like to know my balance, right? And please specify the account type. The account type can be savings, current, and credit. And based on this, specific answer will be provided. So debit card balance, credit card balance, you have another set of intents which are one level down below the account. Now let's try this. Right? Again, I'll just vary it. Instead of saying check my account balance, I would like to know my account balance. And I don't specify the type intentionally. So it detected that he wants to check his account balance. Can you specify the account type? Savings, current, credit. I just enter savings. So it went to looked at my savings account and gave the balance as $345. So you can all try out this chatbot. So I will So I'll just share this URL and you can all try out. So if you have any questions related to chatbots, tomorrow we will have a very detailed session. You can also post right now. We're almost reaching the end of the session.
Okay, sir. So participants, if you have any question, please ask in chat box. Even tomorrow also we have a session with Bhagvan sir, and he will give the next, whatever the topics he has discussed tomorrow, we will proceed further in the tomorrow's session. Sir, anything else from your side now?
Yeah, I'm just sharing another GitHub repository which I've created for computer vision.
Yes,
We can
sir.
use this for tomorrow's examples.
Okay. I request all the participants, please copy this link and save it in your Word file or notepad anywhere else. So it will be helpful to you for tomorrow's session.
And I'll reshare these tomorrow again, just in case you people have missed.
Yes, sir. Yes. Thank you, sir. Thank you for such a nice and wonderful session. Tomorrow we will again meet at 10:30 a.m. for tomorrow next session. I request all the participants please join tomorrow at 10:25 sharp in the morning. Now I declare this today's session was over. Thank you, sir. Thank you so much.
Thank you.